Hello everyone. Today I am going to explain the basic working principle of quantum dot LEDs. In the previous lecture, I discussed about quantum dot lasers and quantum bell lasers. So just like that, here also millions of nanostructured quantum dots are placed in the active region, that is between p-n junction. But here there will not be any lasing action, amplification action. Here only recombination process and emission of light. So according to the quantum confinement effect, the optical properties such as absorption and emission that can be changed, and band gap is tunable by controlling the size of quantum dots, and the color emitted from the quantum dots and the wavelength of emission really depends on the size of the quantum dots. Also, quantum dots have the high photoluminescence efficiency. Check the figure. The effective band gap of quantum dots is based on its size. We can increase the energy gap by decreasing the size of the quantum dots. We know that when you reduce the size of nano layers, actually you are changing the effective band gap between discrete energy levels. When you reduce the size of nano layers, the energy will become more and more discrete. Okay, then quantum dot LEDs are multi-layered structures. It consists of Hall transport layer, that is HTL, then electron transport layer, here it is ETL, and the quantum dot layer as an emission layer, because there will be the recombination process of electrons and holes and the emission of light. So in this type of LEDs, indium tin oxide ITO is used as an anode and aluminium is used as cathode. Generally these are the usual electrodes. And what is the role of a Hall transport layer and electron transport layer? They are used for effective injection of electrons and holes to the quantum dots. Based on the mobility of electrons and holes, we can select different layers. Then there will be a direct recombination of electrons and holes in the quantum dot layer and the emission of light. Indium tin oxide is a transparent oxide. We can also select a transparent Hall transport layer so that the emitted light can be effectively guided to the outside. At the bottom side, there is an ultra clear thin glass sheet for the perfect emission of light. Then the applications. Quantum dot LEDs are used in display devices like TV, then in cellular phones, digital cameras, etc.